Welcome to the Keynote talk at the KDD 2020. Uh, Today we have Professor Filoso will give us the keynote talk. It is my honor to introduce Professor Filoso. She joined JP Morgan at 2018 to create and head a firm-wide artificial intelligence research lab. Uh, Pro- Professor Filoso is also on leave from Carnegie Mellon University, where she is a Herbert Simmons University professor uh, in the School of Computer Science. She was the head of the Department of Machine Learning. Uh, Pro- Professor Filoso is a pioneer researcher on machine learning, artificial intelligence, robotics. She served as the president of Trio AI until 2014. She is the co-founder and a past president of the RoboCup Federation. She's also a fellow of Trio AI, IEEE, Trio AS, and ACM. So today, Dr. Filoso will talk about the artificial intelligence for finance. Um, Welcome, Dr. Filoso.
Thank you. Thank you very much. Thanks for having me. Let me delve into the talk, and I'm going to share my screen. Thank you all for attending. And I'm going to basically tell you about these AI for intelligent financial services, and I'll discuss a little bit challenges, solutions, and then we can brainstorm in the questions and answers about more of these topics. Let me tell you that indeed, like AI, as a science that we all basically, how can I say, practice, is a science that has a lot to do with data, decision making, and action. So we have it's a science of multiple components, and we try when we build an AI system to put it all together. One way or another, that's we vary between making contributions to components and then contributions to the actual integration. I have worked on this integration for a long time, and I'm going to share with you just a few things just to set up the stage or how when I joined JP Morgan. So basically, here is an autonomous robot that is able to see the world through a camera, so gets data from the world, is able to make decisions because these computer algorithms run on these laptop, these decision-making planning algorithms, and actually it moves because it has wheels. So what matters here is that the whole cycle of perception, data, decision-making, and action is integrated towards having these somehow autonomous robot that is able to move around. So I learned a lot from making these robots that they could close this loop of data, decision making, and execution. However, while doing this, there was something very important in which we basically, how can I say, acknowledged that whatever AI system you build,
It looks the internet has some issue. Yeah, let's for wait for Dr. Filoso. Okay, so the Dr. Filoso is working on reconnection. So during this break, if you have any question, please feel free to uh, you can use the QA. There is a button under the Zoom meeting interface called QA. You can, yeah, please feel free to add QA. Okay. Okay. One audience asked for what is the Zoom link for the current session. So yeah, I will ask admin to post the Zoom link. Hey, Dr. Filoso.
I think I'm back.
Okay.
I'm sorry again. I don't know. It's just died, my internet or some connection. Let me
Yeah,
just go back.
that's happened for virtual conference.
Okay, I'm sorry. Okay, so I was just saying that eventually these limitations are inevitable. And so one of the things we have introduced was this concept of actually learning by interaction and being autonomous in a symbiotic way, asking for help and learning. So for example, the cognitive limitations, not the physical limitations in which you cannot learn a new device, a new arm. You cannot learn part of the physical body, but the cognitive limitations we actually can learn. And the beautiful thing about this approach is that you always look at knowledge as something that is dynamically changing with experience. So this robot starts knowing things about the world, and by interacting, asking for help, going to the web, it's always updating. So Cobot did not know where there was like actually coffee in the building or the lab term associated with what, and is able to, how can I say, ground this interaction to actual uh, statements that it acquires by asking for help or by going to the web to find out. So the main two things I would just wanted to say was first, that it's important to think about integrating the multiple capabilities of data processing, decision making, and execution. And then the second part is that AI systems, and this I really want to emphasize this, are not going to be able to do it all, especially from day one. Even if you train a system with some kind of like, how can I say, data, things change. And eventually, a lot of the things we have to worry about is how to keep this knowledge dynamically updated. So these are the two things from the robot world that I wanted to share with you. And now I will delve into JP Morgan and explain to you this JP Morgan problem. So after 30 plus years in academia, I moved to JP Morgan to really start an AI research lab and within this financial industry. And there were many challenges that I had never thought about before, especially the scale. So JP Morgan is basically 250,000 employees, over the whole world. I mean, be it in Asia, in Europe and Middle East, Africa, and then in Latin America and in the US. It's crazy like how global this company is, and it's really a challenge. Very nice. There are 50,000 technologists, people that handle all the computing needs of the firm, and including AI and machine learning. There are like 5,000 branches, 60 million households, 4 million small businesses. So it's a huge company, which interestingly, it's organized along already along four. I'll explain to you four lines of business. I mean, there is the corporate and investment bank, there is the consumer and community banking, there is the asset and wealth management, commercial banking, and then there is a fifth kind of like a group of people that do cross-firm functions. And basically all of these four lines of business plus the corporate corporate functions have embedded groups of people that work on data analytics, data analysis, all sorts of machine learning, all sorts of knowledge, all sorts of rule-based systems, all sorts of like trying to bring computing to the functioning of the lines of business. And then there is, while building these, there is shared AI services that are available for these multiple businesses. And then there are also shared AI analytics services. They now not just the actual menus and data and all sorts of like infrastructure, but really also AI analytics and also data services. AI research, which I lead, comes across or covers all of these aspects and tries to bring, in some sense, more of transformational thinking to the firm, thinking about what AI can do for the business. So that's what I'm going to tell you now. It's basically, I'm going to tell you a few things, but the important thing is that I bring also to the firm through this AI research a culture change. The culture change is very similar to what I told you about symbiotic autonomy, in which we think about AI systems as a lifelong problem, in which they improve with experience, they learn, improve over time, they learn from experience, they ask for feedback, they start with a few examples. So the science here is not about a classification task today, but it's about thinking about AI for life. What is this AI system? So you build a model from data, you get some feedback, positive or negative, you make some predictions, and then eventually you fix the model back to the, you are in this kind of model, prediction, feedback loop, and eventually over time, the AI systems improve. So this is something that is very dear to my heart, which is the concept of AI, not as a one-shot problem, but as a continuum, and trying to build systems or understanding solutions that improve over time. So I'm going to mention to you 6 projects, and then I will stop for questions. So one of the projects, the 2 projects that I'll start with is Mondrian, which I'll present, and then there's IGAze-based decision explanation, which I will start, our joint work with Naftali Cohen and Tucker Balch. And I will follow up now explaining these 2 projects. So let me tell you, like, what is this trading all about? So trading is a difficult task. The electronic trading happens later when the decisions are all made. Then the execution is done by the algorithms, the electronic trading algorithms. But before the electronic trading algorithms, there are humans that take requests from clients and basically try to schedule the trades for these electronic traders to actually perform them. But all of these people, the actual traders, the people that are in the trading floor, basically look at these screens. And we have seen them in movies, or at least I had seen them in movies, but I did not have seen them in person. So when I enter this trading floor, and I'm like, there people very kindly are explaining to me all the challenges of this particular kind of function, I could not stop but seeing these screens. And I knew that basically humans were surprisingly, these traders, not using any artifact manually or some kind of paper and pen or some kind of like math. They basically were looking at images. They look at these images and they make decisions buy, no buy, or whatever other decisions they make by looking at images. And that actually, these images, for which we know that these how do you say, this time series data has been studied with many mathematical functions, Bollinger Bands, all sorts of RSI, all sorts of techniques to try to predict where these very nonlinear, complex time series is going to go. And a lot of these has been done with some success, relative success, but still these humans are not doing any of this math, and they basically are looking at images. So we know, we in AI and machine learning know that we invented this technology, this deep learning, which works really well on images. So deep learning has been working on classifying objects in images very, very successfully. And in fact, there are thousands of objects that are identified in images with very high accuracy by our deep learning algorithms. So it's interesting that we have been thinking about images of objects, either for autonomous driving or for distinguishing cats from dogs. It doesn't really matter. But our images have been capturing objects. So basically, what I wanted to tell you is that we at JP Morgan started looking at these images of a signal moving over time as these images that were on screen, as images themselves. So not as data, capturing the time series data, but as an image, a pixel-based image of that function. So it was not a cat, not a dog, but somehow we created a representation that's a visual representation. This is a candlestick representation. It really doesn't matter, but it captures how the signal varied here. And that's like within some window, a picture of what the signal looked like. And then we trained a neural net with these images with labels buy, don't buy, according to the training data that we had from human decisions buy, no buy. And we were able to learn with 95% accuracy and 94% precision on historical S&P data, reproduce the same decisions. So this is like a very interesting kind of like, at least from my point of view, trying to bring this understanding of AI also to the financial domain, but beyond, because now what we have been working on, and this is just the beginning, is that this Mondrian system is able to basically classify images that are not objects. They are images of all sorts of like visualizations, be it time series data. And in fact, if you train with the actual values, the neural net does equally well, one way or another. But the point is that now, through this Mondrian, you can train on other things rather than this time series. You can train on other visualizations. And you can train to capture the decisions that humans make by looking at actual images and classifying them as, yes, class A, class B, buy, no buy. And so there is this first project that I wanted to share with you is this concept of being able to apply technology of classification of images also on images that are not objects necessarily. There are images of other things, in particular, images on your screen of time series data or images of any other sort. So this is the first thing I wanted to tell you. And it's not that Mondrian is deployed and now basically we have a trader that uses images yet, but I want you to understand that maybe one day we may be able to use these on the trading floor to have this AI system do it differently and hopefully learning to do it as well or outperforming how humans do it. We don't know. It's just that I'm sharing with you the definition of a problem of learning from images within these images that are capturing how assets are changing in the market. So this is the first contribution. The second one that I want to tell you is the following. It's very hard in these types of decisions to know why did you decide buy, no buy. And basically, it's not easy to come up with an explanation for a good trade, nor for a bad trade. So this problem of justification, even for humans, is very hard to justify why this decision was made. So when we were doing this, again, looking at the screens, we thought about that somehow people make decisions because they look at things on these multi-informational screen. So these screens they are looking at have a lot of information. And we thought about following the eye gaze of people. So we built this experimental setup, again, with Tucker Botch and Naftali Cohen. And we built an experimental setup in which we could track what people were looking at in the screen. And so these gaze patterns somehow track the sequence of attention points and hopefully explaining the behavior of, or the justification, what supports the actual decision was because I looked here, then I looked there, then I looked this, and then I made the decision. So it's interesting that we are used to thinking about speech as capturing our thought, and we do chatbots, and we do all sorts of understanding of text and speech, but to use eyes, and we do eye gaze to track that if someone fell asleep or not. But the actual eye gaze can also capture what is the attention sequence of people. Even if you have a little bit of noise and you look to the side or you look somewhere else, somehow there is a signal of sequencing that your eyes are actually revealing if you capture these eye gaze. So we were able to think about this gaze pattern sequence to explain activities. So if this is a screen, and if here you see in this right-hand side that we can actually track like that the eyes of this person started here, the size of these red little balls is how long you were there, then it jumped here, then it jumped to the other one and so forth, and then you made the decision. So there is something interesting about this. Your eyes touch these points for more or less time. And these kind of touching also says the places where you did not look at. So maybe with peripheral vision, you could have seen it, but you did not look at these two. You did not look at this one. You basically looked at a sequence and you made a decision. So we have been investigating these associating explanations of decisions to when people make decisions based on looking at actually a scenario and using the places that people looked at to justify a decision. So this is another second thing I wanted to tell you. And here I can show you a video of these just tracking these areas. So here is the system working in the sense that it's able to see this blue region first, then went and jumped to the yellow region, and then it went back to the red region, and then the blue region, and the yellow region, and so forth. And you can basically understand, I mean, you can capture the data of the sequence of topics or areas that the human looked at before making a decision, okay? So this is the second thing I wanted to tell you. Oops. And so I told you about these Mondrian, these like gaze-based decision explanation. And now I'm going to tell you about synthetic data generation. I'm not going to talk about SMPC today. Sorry, it's here, but. So I'm going to tell you one more now, so the first thing I told you, this Mondrian and the eye gaze are about using visual information. And it's like this data for the decision making about buy, no buy, and eventually getting feedback on whether this was right or wrong. So there is this first aspect. And I am going to now focus on another example of applying our AI and machine learning science. So there is something that we in the KDD world and everywhere in AI, we really value, which is data. You know, people more and more value data. And for sure, JP Morgan has large amounts of real data, large amounts, thousands of transactions per second in payments, thousands of millions of customers using all sorts of like facilities, accessing, making like loan decisions. I mean, all is in the hundreds of thousands, in the millions. So a lot of real data of the whole world. And we know that this real data is precious for AI and machine learning development and research because we rely on data. The problem is that in some sense, there is these privacy issues, and there is like these confidentiality issues that do not enable the real use of this real data easily. Even if we would anonymize, first of all, the sizes are gigantic, and one way or another, we don't know yet very well how to make this real data available to everyone for research and for development. So we have been working on how to build upon this real data. And the interesting thing is that we are trying to build also on examples that we very much value throughout our career. For example, there was this UCI machine learning repository that really changed because this repository was able to make available data for many different researchers who could actually, how do you say, compare the performance of their algorithms on that data at UCI, at the UC Irvine repository. Then, you know, OpenAI beautifully and very, very interestingly is making thousands, a lot of like relevant data available, especially also for reinforcement learning. And it's this gene data that we love to use and to support the research that we do on reinforcement learning. And also now multi-agent systems. And OpenAI has been, like in the 2000s, an amazing example of these making data available to research communities, in addition to all the great things they do. And then CMS is an example of, in the 2010s, of real payment data from the US Federal Healthcare Services, which was also made available. So there are these examples of data made available. And so that made us build this project called Mirage, in which we are generating synthetic financial data. So the data that we have, and we'll make available to anyone interested, stay tuned for an announcement soon of this data being made available in general, is synthetic, so it's not real. However, the science here is about how to use the real data to make sure that the synthetic financial data is still realistic enough based on the real data. So we have one way to do it, and one way to do it is by reproducing statistical characteristics of real data. But another way to do it is actually by generating data, especially for markets, which I'll explain in a second, with trying to do a multi-agent exchange market simulation. So again, in collaboration here with Tucker Balch, David Bird, and other people in our team, we are building this Abide system, and Sami Assefa has been doing all the development of the synthetic financial data, and also Mahmoud. But let me explain to you what this is all about. So, we don't have an easy way of making the real data available. What we invest on is to make a real good simulator, and then use the data of that simulator to really become the synthetic market data. So the market simulation Abides captures includes an exchange agent, which is just a New York stock exchange, a learning agent, and more traditional. Abides is a system that supports simulations of thousands of these agents and is high fidelity in the sense that works at the same frequency, the nanosecond resolution, and so it can almost continuously simulate these traders. But what's interesting about this is that because we are looking at this problem as an agent-based simulation, we can, how do you say, control, or we can model different ways of being in the market. So we can have different types of agents, and then we can have also a learning agent. And what happens is that by having this kind of like, how do you say, flexibility in having these agents, we create different types of markets. And then the challenge, or the interesting thing from a synthetic financial data point of view, is that you would like that this data generated by Abides, not the real data, but because Abides as a research goal tries to understand if it can capture the same statistics, the same series as the real markets, we are able to generate synthetic data generated by Abides. So somehow these multi-agent market simulation, as you can see, can create an infinite number of similar market days, can be generated using similar configurations of these agents. We can basically play with knobs and change the trends of the regimes to see what the data will look like, the market will look like. And so this is one method that we will make available to everyone. In fact, Abides is already like available, and you can use Abides as generating market days that can be used as actually synthetic market data. So just to tell you, I told you about Mondrian images, all problems of like using data from a visual point of view to capture decisions. Here I'm telling you about this data, the value of having this synthetic financial data that we are trying to make available to the community, to universities, to ourselves, to the research, to anyone that wants to use this particular kind of data, synthetic data, that eventually captures the real data as best as we can, at least from a statistical point of view. So I mentioned to you these Mondrian anti-gaze, then I tell you about the synthetic data generation, including this multi-agent based market simulation with Mahmoud. And now I'm going to tell you about two other projects, and then I'll finish and I'll answer questions, which are very, very interesting too. And the different that I chose also targeted for our KDD audience and trying to understand this issue about data, which is everywhere in our JP Morgan world. So let me tell you about this data intelligence, just one example of some work we do with data, a lot of data, and which is led by Rob Tillman, Vamsi Potluru, Jaha Shah, and Prashant Reddy. And of course, I am also part of this effort. So let me just explain to you what's happening here. So let me try to explain what happens in terms of like these data intelligence and what can we do in terms of AI for these data intelligence. So there is a problem called data in placement and another problem called data in motion, deep and dim. And basically the problem becomes the following. So you have all these data that happens to be available in the firm. There are thousands and thousands of, be it like, you know, relational databases, be it like, you know, data in any form. And the data exists and is being used and is transferred and reused between multiple applications. And the question becomes, are we actually using the right data? Is the data actually correct? Are the things that depend on each other correct? So this is a problem of cleaning the data, and how can AI help with this? So one approach is to assign concepts to this data, which is you try to label the data. This is about a transaction. This is about fraud. This is about like a customer. This is about like all sorts of like payments. So you have these vocabulary of concepts, which happens to be in the 500s or something. And then the question becomes, how do we label these these different like applications that use the data, and how do we link these concepts to the actual different concepts through these links? So I'm going to explain. So this is a paper that is being presented at ECI this summer. But let me explain to you what I mean, and you are going to, the analogy is going to make it very easy to understand. So think about Facebook or LinkedIn or a network of the people in your building or Amazon customers or whatever you want, in terms of like thinking that these nodes are these people, A, B, C, D, G, and so forth, are nodes, myself, who, for example, I could be node A, and I am in Facebook, I'm in LinkedIn, I'm a person in my building, I'm an Amazon customer. So these multiple being in Facebook, these are all labels, these are the concepts. So we have these little kind of like nodes, which are like the applications in JP Morgan, and these labels, account, trade, rate, are the different networks that you are part of. So this means that application A is linked to application E when we are talking about the concept of account. So, for example, I'm linked to someone in Facebook, I'm linked to someone else, like if I imagine all the people, all my friends, if I think about Facebook, I might be linked to other people when I'm thinking about professional LinkedIn, or I would be connected to other people when I think about the concept of people in the building or anything. So just so you understand, these, we all belong to different networks, and the networks have labels, Facebook, LinkedIn. Here is the same. Every single one of these applications, these nodes, are connected for a purpose, for accounting, for trading, for rate, and they exist and they are connected. So what this algorithm did, okay, hold on. So the challenge here is how do we infer unknown data flows between applications? Basically, do we know if D is connected to E for trading? So we need to know if those two applications are connected with some data flow for a particular concept. So humans may have failed to document these data flows. They have documented some, but we don't know if they're right. And we are talking again, thousands of applications. We are talking about thousands, and I'll give you the number soon, about these edges. So these existing data flows, actually, the science here is that any correlation revealed in one network can provide information for other networks. And in our real life, you know, when you get recommendations for connections in Facebook, I don't think that they use LinkedIn, or I don't think they use the people in my building to whom I'm connected. They work in a single network. So the contribution of this paper was really to use information in one network to happen to clarify. I don't know why these are not in the right place. I apologize, the pictures. But to use information in one network to really try to infer things about the other network. So we define this concept of network correlation between the data concepts in terms of network structure. So we are able to say, how are these two networks correlated by really computing the structural property for data concepts, these basically the shared links and edges. And we apply the, you know, these particular kind of like a vector to capture, to quantify how these two networks are correlated. So let this network correlation be defined in any way you want. We use Pearson, but we now combine the network correlation for this count and weight correlation heuristic with information from other concepts. So for example, let's see, if we want to actually estimate if A is connected to D, if A is to D is a missing data flow of some concept. So if I miss to be like connected to someone in LinkedIn, we estimate basically for all the other graphs, what is we go through it and we see if it is true that A and D are connected in the other networks, and we multiply these by some value of the correlation between the two networks, we are able to then compute what is this heuristic that tells if this flow is missing or not. So interestingly, and I'll show you now these actually so the algorithm is that while there are concepts and apps such that either given a threshold of how much to add and how much to remove in terms of consistency of the networks, you add all flows and you remove all flows such that the actual count and weight correlation is larger than what you want to add or smaller than what you want to remove, and then you recompute. So basically you are doing these robust entity tuners, so you are tuning these two networks as a function of each other. And interestingly, for example, I'll show you these metrics. For example, if we set this 0.5 as the heuristic value for these count and weight correlation, the CWC, will be larger than 0.5 for all concepts, then we are able to show that several removals and several additions are suggested by the algorithm, and the numbers here don't really matter that much. But what matters is that here is an example of an initial state of the concept document. So think about Facebook, doesn't matter, some kind of concept. And through multiple steps in the algorithm, it converges to a different type of proposed links. And we are able to then validate that these links are better than the initial ones. And here is another example in which a network that started with these links converged to the network of these links. And this is another more complicated, the transaction concept, another more complicated network that again converged to a different network. So just to tell you that the contribution here, and please follow the paper, and we have at JP Morgan a website with all these papers available. The interesting thing here is again this concept of trying to start with some knowledge, which is represented in different networks. So the structure of the network captures the connections between all these concepts, for all the concepts between these nodes, and then find this metric that enables you to infer missing connections in other networks by somehow computing how similar or this network correlation between different networks. So this was the second example. And then I just want to finish by showing you these AI. So the last thing I'm going to tell you is these AI PPTX. So let me just tell you something. So I told you about Mondrian. So if we go back, I told you about Mondrian and these eye gaze, all about images being classified through applying a neural net, through where the contribution here also is the use of images for other things than objects, and trying and showing that in fact can still be classified with if we have decisions made according to some visual pattern. Then I told you, I'm sorry, I don't have here the secure multi-party computation, but I told you about the synthetic data generation, the multi-agent based market simulation, and now I'll tell you about another contribution, which is this AI PPTX. And this one, in some sense, is the, again, closes the loop between data and actually execution. So let me tell you one final thought here before we go to questions, and which is the following. So at JP Morgan and many other places, we have to produce lots of documents, lots of, like, how can I say, from PowerPoint slides to Word documents. And basically what happens was that this particular kind of like necessary representations, PowerPoint and Word documents and reports, are a transformation from data that is in some form, like, for example, an Excel file or a relational database or some kind of like graph, knowledge graph, doesn't matter, into a different representation. So there was this thing about understanding if we could automate this process of translating from one representation to another. And so we did this. First, this was the first thing we did, which a system we called AI PPTX, because we are able to generate PowerPoint slides, actual PowerPoint slides, by translating the commands that people state in English, human language commands, and associating with those human language commands what the visualization in PowerPoint should be, and we automate that translation. So if you say, add a slide with satisfaction scores, insert a histogram from Excel file data.csv, and use column C of the Excel. And so you map these, and the satisfaction, this slide was completely automatically created by going from that command in language to transforming, applying those skills, those requests into the representation. So you are making a translation from one representation to another automatically. This is a tremendous impact at JP Morgan because, or in any company, because the data is very cryptic and the visualizations are very informative, but they are tedious. They are, how can I say, when you think about thousands and or even millions of PowerPoint slides to be produced annually or to be produced in a particular line of business, these becomes very tedious to make and becomes also very prone to error. And so automating this process of changing of representation is an interesting direction to show how AI can empower employees on doing their job better. So this is not a trading issue. This is not an actual data issue per se. This is about assisting employees with methods that they can use, the AI methods that they can use to empower their functioning. So I'll show you a video, which is, I believe, quite compelling. And this video is about showing the interaction between the AI Power PPTX expanded to templates, large numbers, decks of slides. So here I'll explain that CFIT, it doesn't matter, it's a very business, it's an area of business. And they actually, let me just stop, oh, sorry. Let me just show you. The point is that CFIT is really good at creating decks of slides. And now AI PPTX, this AI system, can manage the mapping between the language, create a company briefing deck for J&J. The system does not know what J&J is, asks, I'm afraid I don't know. And they say J&J, and now you know everything. Now run the analysis. And these particular slides are all generated automatically by mapping the actual requests from the humans into these primitives, these skills that transform language data into visualizations. And then easily you can say, do you have any instructions for me? Okay, add a new comps group met deck to the deck. Do you have other instructions? Remove Sanofi from the pharma comps group. Do you have any instructions? These are all language typed by humans. Yes, modify the time series duration to 1 year. So you can have this language, which the system also learns to what do they mean. And basically then it executes this time series duration was reduced to 1 year in one shot, because you say reduce to 1 year. Then it just calls these with different parameters, and all these slides are applied, these all updates apply to all the slides, and it ends. So this is a very interesting kind of example of the power of trying to do automation and AI. And we also, now, in addition to PowerPoint slides and language, we have been working on translating these, so creating automatically, how do you say, natural language insights from analyzing data. And we can generate, I'll explain to you. So these particular kind of like left-hand side, these language is all generated automatically by this AI financial insight system, similar to the AI PPTX, in which basically the generation of a report is automated, requests of human language and human needs to the actual report. And this is a 300-page report that we are able to generate automatically, the part that is about the insights, the financial insights, these type of like capability, these commands, and they are very parameterized again, enabling both the system to learn from human input and the humans to specify their needs in terms of these parameters. So in conclusion, I just want to say that there are a lot of other projects we work on in terms of this financial domain, bringing AI, bringing automation, bringing machine learning to try to improve the way, or to try to make it more robust, the way that the business works, or the way that this financial domain offers challenges to us in terms of scale, in terms of accuracy, in terms of regulation. And we have been working on learning customer satisfaction, detecting and preventing financial crime, regulations and compliance, fairness in markets, ethics and values, and client experience. And all of our work in these AI research at JP Morgan can be organized and is organized along 7 aspirational research goals. And we want to understand how AI can help to eradicate financial crime, how AI can help to liberate data safely, and AI to predict and affect economic systems, while also in terms of our stakeholders, if you think that the stakeholders in the financial domain are your clients, your employees, the regulators, and you'd like the AI to perfect the client experience, AI to empower employees, and AI to agentize this policy compliance so that we can improve the mapping between business and regulation. And then an overarching goal for all that we do at AI research at JP Morgan is really this establishing ethical and socially good AI. So in conclusion, I just want to conclude for our audience that the key enablers for this, from my point of view, head of the AI research group at JP Morgan, is that we want, and we have been developing long-term relationship with top AI universities and technology firms to actually establish these interactions to make you understand all the academic community and practitioners that at JP Morgan we are actually pursuing a lot of AI and machine learning goals. We want to establish we also establish continuing interactions in the internal community to accelerate AI in the actual kind of like within JP Morgan. And we, and also I'm very thankful for this invitation also, because we want you to understand that JP Morgan, it's not a technology company by definition, but it's a technology company by execution. So the brand of JP Morgan Chase within the AI community is really a company that cares about technology for the financial services. And so if you are interested on knowing more, you can go to jpmorgan.com/AI, and you can send me email at jpmorganchase.com. And I am, how can I say, this is like what I work on now, and I'm very much looking forward to any questions you may have or any contacts you want to make. And you should know that we have this inaugural conference of ACM, International Conference on AI and Finance, ICAFE, which is going to happen 15 and 16 of October, unfortunately virtual, like we are doing here for KDD. And this is the first conference, which is actually led, the program chair is Tucker Boch, and the program committee involves several other people, and including Mike Bowman and Michael Woodridge and several other people. And you are all invited to attend. And if you search for iCave, you'll get to the website. Thank you very much.
Thank you very much for wonderful talk. Now we do have a lot of questions. So yeah, we may start from the earliest one. So the audience ask in your first question, in stock market, when the data are labeled as buy or don't buy,
Yes.
usually we associate the buy and sell action together in order to make a profit. So what's the reason behind of labeling it as buy?
So it's a good question. I always get this question, which is, what if the decision was not the right one? Or so here the goal was not really to outperform the traders and do better or learn the best trader. We don't know. We were using data that is publicly available of all the decisions that were made for a long time by different traders. So we were not learning from a good trader. We were not learning from to decide buy, no buy, that was the right decisions. We were learning to classify that those decisions had been decided to be buy and no buys. And there was a lot of consistency one way or another by how the signal looked from a visual point of view and the decisions that were made. Actually, we were able to reproduce 95% of the same decisions based on images of these signals. So, you know, we can talk more and more about trading and more about like performance. But what I wanted to share here was somehow the use of images to classify decisions, not just to classify objects. And somehow decisions, think about EEG decisions. You go and make a stress test and something, or for your heart, something comes out as a signal out of that and actually printed. The doctor comes into the place where you are taking the test, looks at that signal, and she tells you everything is right, or now you have a problem. And that person is able to look at how the signal is changing, and make a decision on whether you are healthy or not healthy. And I believe that the only thing I want to say here is that, you know, we have been in the community using images for objects, apples, oranges, bicycles, motorcycles, cats, dogs, and somehow images can't capture much more than just objects. That's what I'm saying. Stop signs, whatever we have been using in autonomous driving. A lot of things have been used about the physical world. And I say that many things we do may use images of other nature. That's what I was trying to capture. Thanks for the question.
Thank you. Indeed, there is the other related question, because the image came from the structured data, so the time series data. So we have two ways. One way we can use, for example, CNN to do clarification on the images.
Can you put your? I cannot hear you very well. Is that a way?
Yeah, sorry. Yeah, we do have the other question, the related question. So sure. the image came from the structured time series data. So we do have two ways. One way to using CNN, for example, CNN to classify the images. The other way we can use like RNN or LSTM to classify the time series data. So did you compare these two different ways?
Yeah, I think we did a lot of studies, and I'll be happy to send the paper so you can read. I mean, I talked about this for 2 minutes, and we have been doing this for 2 years. And so there's a lot, we've done a lot of comparisons, even like with data, with different types of networks, LSTM. And so the important, again, like what I was trying to get across to all of us was this concept of using images for classification of other things than objects, okay, and decisions. Very good. But again, if you see the papers, and you will see the different things we compared against, many things.
Okay. Yeah, we have too many questions, so I will pick up maybe two more. So how does how does your team measure the quality of synthetic data? Because you generate lots of synthetic data. So how do you measure the quality?
How do I do what? Sorry, Heng.
Measure the quality of synthetic data.
Oh, the synthetic data. How do I manage the quality? Is that what it is?
Measure the quality.
How do I evaluate the quality?
Yes.
Okay, so the important thing is like this. So in the synthetic data, we actually currently we're more first interested on how can I say, generate, in quotes, legal synthetic data. Legal in the sense valid. So think about that if you have like if you would like be generating data about chess games, right? So you first wanted to generate data that is valid. So you don't want to have wrong moves of the queen. You don't want to have the king being checkmated and the thing does not deciding checkmate, versus excellent games that you are making available. So currently we are generating synthetic financial data that is consistent according to the rules of the game. I mean, you cannot put an order in the order book in the trader. You cannot put a request for buying and selling of the same asset, and then you have to match. If you want to sell 100, someone needs to buy 100. You need to match them. You need to compute the right price. You need to have the data be consistent with the rules of the exchange stock exchange. So the first thing we are trying to do is also generate data that is actually valid data. It's not random data, but and we are trying to. So think about going from random data to valid data, and now to actually being realistic. And we validate this by sometimes, for example, for the markets, we really have a way to. We validate the agents in the simulator. So we have bytes with agents that can, with some error, but closely reproduce historical data that we have of the markets. So you have historical data, and then you have these parameters of these agents that you have, and you try to find what should the agents look like, which would eventually generate data statistically very close to the historical data. When you fix these agents, or when you find these agents, which we do, then you run these agents in new markets, and those become now the synthetic data. So we validate first what the agents are based on historical data, and then we let them go in new markets, and we try in new order books in new markets, and then we don't have a way of validating that new synthetic data is real or not, but we actually validated that the agents were able to reproduce historical data, and therefore the agents are realistic. Okay.
Okay. Thank you. Yeah, maybe last question. Yeah, we know, because we do get an internet break in the middle. So one audience asked, what was the greatest challenges for the implementation of the AI culture in JP Morgan, and what's your advice for people to bring this culture to other companies?
I think that this is the, how can I say, besides the technical questions, this is a very important question, and thank you very much for asking it, because one way or another, that's really the thing that I can answer. So I've been at JP Morgan for 2 years, right? So you have to understand that indeed, there has to be some willingness in your industries, in your companies, to really, how do you say, delve into the power of AI and machine learning for the functioning of the firm. Because, as opposed to Google, Amazon, Facebook, and all sorts of other companies, those companies they were actually born digital. So they were born already. This was why it was told when I was recruited to come to JP Morgan made me a big difference, because they were already born thinking computers are going to do this. I'm going to learn recommendation. I'm going to make recommendations. I'm going to represent knowledge in the right way. It never had like humans doing Amazon purchases for you. It was always from day one a computer algorithm. But that's not the case in JP Morgan. That's not the case in healthcare. That's not the case in construction. That's not the case in agriculture. That's not the case in cities. That's not the case in government. So these things all existed before computers came out and AI and machine learning and data came out. So in some sense, the question is really to the point. I believe that at JP Morgan, the reason why I have been able to be involved in this transformation is because the leadership really believes that there is a benefit from investing and from thinking this way. I mean, this thing about Mondrian is disruptive enough that in fact it's not yet deployed, but I insist with JP Morgan showing them what things can be done differently, and they are extremely receptive. So what I'm saying is like this. I don't know if this is the right, how can I say, the most politically correct advice, but I need to tell you one thing, or the right advice. I need to tell you something. If you are in an industry, the way to actually challenge is to think with your own head of a scientist, to think with your own head of an AI and machine learning, and to really contribute to the industry your genuine ideas of how could things be different, being detached from the fact if they really are going to implement them or not. If they are not, okay, well, but you cannot compromise and not tell what you think would be a good way to do things differently. You don't know if they would be more effective or not, but you are the technologies. I am the technologist. I'm saying, well, these look like images. I'm sorry, this looks like actually we can automate the PowerPoint generation. Yes, you know what? I think that, we can create synthetic data. These were things that started from us offering the business, and then eventually the business, will have a way to eventually grow into these transformations or requesting us to think about other transformation. Financial crime was something that I never thought before. And the business made me think, oh my God, this financial crime is so important, these frauds, the money laundering. And we are doing tons of work on PageRank application to money laundering, behavior simulation, tons of things for financial crime. So I think that the culture, we have to be, we can change the culture if we bring innovation to the thinking of the business. And of course, there is the applied part in which we have to actually execute the things that may be needed tomorrow. But me being an AI researcher, it's not that I am, I can afford not to be like worried about the things that need to be there tomorrow, but I can, move around trying to bring new ideas, new concepts, and some of them become immediately adopted and some don't. But you are trying to find where are the things that will make a difference, So it's not going to be, it's not going to be devised by only AI researchers. What's going to make a difference in the business? These business people and the business where I am, JP Morgan, they are the experts of the finance domain, not me. I'm not the expert of a finance domain. I don't know really all the things that traders need to worry about. So I am a naive observer with a lot of experience on another area, which just happens to be AI. So you change the culture by being open and by being absorbing what they're doing, and just by being there. I mean, I sleep less at night now than I used to sleep when I was at CMU, to tell you frankly. I'm always thinking about all these things. What can I do? Now it's the return to the office problem. What can we do to help? What can we do to do like reports better? What is this, all these challenges? So you start thinking about what can you bring? And then, but also you accept them as they are, because, they have a business to run. So it's a difficult question to answer, but it's more of a like, how do you handle it? And I'm not saying I'm handling it perfectly or not, but I'm enjoying the interaction, and I don't give up on bringing novel way of thinking. So I'm always trying to bring my little novel things, my 2 cents into their thinking, acknowledging that they are the experts in finance domain, not me. but I'm still there and they brought me there. So I cannot just give up and say, yeah, I'm doing the way you want, because they don't know about technology and I do. They don't know about AI and machine learning and I do. So they are humble to recognize I know, and I'm humble to recognize they know. And somehow with this generous kind of interaction, you are able to hopefully advance these culture change and hopefully for the better, one way or another.
Thank you. Very insightful. Oh, yeah, indeed. When we check schedule, we find we still have some time before next session starts. Would you please take several more questions?
Yeah, I can take a couple more. Yes.
Yeah, thank you. My audience asked for the last topic when you talk about AI PPTX.
Yes.
The audience wants to know, is it possible to use the AI PPTX to generate slides, for example, this presentation? So is it focused on particular domain or could it be used for general?
No. Believe it or not, this AI PPTX is very general. We did not create my own slides for this talk, for sure. So, but I'm trying also to actually have I'm trying to automate my own the generation of my own slides by selecting the right ones and organizing and enhancing and putting, but it didn't. But it's very general, very general. And in fact, we are also going to release a version, and we are working on it such that even like for the reporting, such that it applies to any data. And basically, I tell you, here I didn't emphasize as much, but basically it actually is able to learn these correlations between how you report and the data by looking at examples of the reports, examples of these PowerPoints. So if someone does a PowerPoint slide generation that captures like the transactions of some customer last month, a monthly report for a customer, if you see several of these monthly reports, you magically kind of can learn that these two fields here in the image come from these two fields here in the file, and you are able to learn how the data was extracted and represented how. So we are trying to do this. Of course, you and I know that if the computation that was performed on the data was not one of the possible computations that we think could have been done, and suppose that they were doing a square rooted divided by some prime number and then multiplied by some exponential. We know we cannot reverse engineer easily that number came from that function. So that's complicated. But if the relations are addition, subtraction, averaging, max, mean, all sorts of other functions you could perform on the data, given examples of the reports, we currently are able to really, learn to generate the new deck of slides, a new report from looking at past reports. And we are working on that. And definitely also another direction from coming also from AI PowerPoint, the PPTX, is this thing about enabling to map language commands, put an histogram, words, draw these, to actually executing skills. So we are doing this we call this also learning from instruction, that the human instructs the machine what to do using language. And we are working on that too, because after all, these humans know a lot. They know what to do. They just, unfortunately, have to do it. But if they would have a way of telling a system what to do and to really have the system understand from the language, what does it mean in terms of execution of what primitives, then you could enable these particular kind of humans to train or to instruct the system to do something. So the AI PPTX is both a problem of language to execution and also an opportunity to learning to execute given examples, okay? So there is a lot on trying to execute these particular kind of how do you say, systematic changes, because they have translation, because it's like language. You don't, when you do translation, you don't invent a new word. You try to map, you know, bear with how you say bear in Portuguese, urso, or you are to try to say, you try to map existing words. You don't invent new words. And somehow this kind of like generation of reports is also a mapping and trying to understand this mapping. When I say this, what does it mean? How I represent? So we are in kind of a closed space like dictionaries. I mean, of course, how you put them all together, it makes a very difficult problem, and context and whatever. But don't forget that the dictionaries are fixed. It's in fact the sentences, the sequencing that are difficult to translate, but somehow the dictionaries are fixed. So if you have fixed primitives that can put things on a report and fixed primitives on how can you talk about data, eventually you learn how to map. And this is a lot of the things we do. But I just to reassure this person who asked the question, this is not, so this is the difference between AI research and some applied AI. So if you are solving the problem of the PowerPoint slide generation for the particular lines of business, you do a great, how do you say, application. We are trying to understand the problem that applies to any PowerPoint generation in all the firm, even across, outside, or to different reports. So we are trying to understand what is the essence of this problem and trying to address it in general. And of course, then the instance and the special case are also, you know, benefit from this. But that's really not targeted at solving a particular problem. It's targeted at understanding how do we do this in general. Thanks a lot for the question.
Oh, thank you so much. Can we take the last one? That's really last question.
Sure. Yes.
Okay, thank you. So one audience was asking, when you do the market prediction, did you consider using the customer's sentiments or news along with the images?
Very good question. And in fact, I don't know who asked it, but if you want to join JP Morgan, I take you, you know, for to do this. This is something that is fascinating. We have studied herding theory, all sorts of like you say, sentiment analysis. It's a difficult problem. It's a difficult problem. And somehow I have to tell you, we have done a lot of progress on separated. I mean, on sentiment analysis, maybe there is a lot of research done at JP Morgan on trying to understand, but merging sentiment analysis with trading, with herding behavior, with this, with that, that's harder. And we are using these, and any good ideas, that's why I would say I thank you at JP Morgan, because any good ideas will make a difference. Now, one thing I have to tell is that one day maybe, if lots of these things are made by computers and AI, maybe there will be more algorithmic analysis rather than actual undecided sentiment analysis. So we don't know yet very well how the world will be like one day if everything is done by, so a lot of these repetitive tasks are done by AI systems, but we'll see. But yes, we have not combined yet with sentiment analysis, but we are trying to too, but not yet. So you have to, I just want to wrap up by telling one thing. So I chose these 6 or 7 or 5 projects to tell you about. Our AI research, you know, captures financial crime, which I didn't cover here, you know, data, policy compliance, client experience, employees' functions, predicting these complex systems, values. I didn't tell you anything about fairness in markets, fairness in lending. So, you know, it would have been a much longer talk. I chose a few of these things to tell you about. But please, from time to time, go to our website, look at it, and maybe we'll see each other at some other place, some other time. I'll be happy to talk with everyone. Thank you very much.
Thank you so much. Yeah,
thank you.
Let's
thank you very much.
conclude the keynote speak. Yeah, I do have the audience. Thank you so much for a wonderful talk. Yeah, we learned great.
Thanks to everyone for the questions. Thank you very much. Bye-bye.
Thank you. Bye.
Bye.